Hey, good morning. So, on this stream, I'm going to be continuing my betting research. I'm going to be working on this. Performance on analysis 1 trend 3. What's that bottlenecked by? Till I can figure out how to define the region. Okay, I forgot I took that card off, so this isn't bottlenecked anymore. It's just our highest priority. Um, I mean, we might as well make it bottlenecked because it's true. Well, no, that's not true. Yeah, let's make this bottlenecked until we can say figure out how to define region. And this is a bottleneck reliever. All right, so that's what we're up to today. We're gonna try to do this, and I think my mic might be a little close. Nice, so that's working. Let's break this out. And I'm gonna try to pay attention to the chat. Um, okay, so back to where we were. Um, yeah, so we're trying to figure out how to define this region. Here's what the trend looks like. So we want to exploit this trend. We want to find a way to draw a boundary around this blue data here. Because that's where that's the blue data is a win for the home team. So Um, what we're looking at here is in this region, when the odds are moving around here, um, it's almost always a win for the home team. But the same trend doesn't appear up here for the away team. So this is a home field advantage thing or something like that. Um, so we want to exploit that trend. Okay, so in order to do this, we need to automatically generate that region. Let's see how this is lined up. Okay, nice. So to do that, we need to automatically generate the region as the first part. So, oh yeah, and we should also put into here our data from yesterday. So can delete that slide. Forgot to save this yesterday after I was working in it. So first we should go put in the analyses from yesterday into our PowerPoint. So total analyses, PAT, V, performance against total versus performance against total. And we have it going back one game, 1, 2, and 3 games for the 2018 season. All right, put that in. All right, now for the next slide, we have total analyses. Swing versus performance. All right, and that we also have 1, 2, and 3 games. All right, and finally just one more. And yeah, there's not many patterns we can draw from this. Um, all right, one more slide. And there's no patterns, but when we go back and look at um, data, we want to be able to say, hey, we looked at everything, and let me just scroll through my PowerPoint and pull up the data I'm trying to look for. All right, swing versus performance and swing versus swing. Yeah. All right. Okay. Now this, we want to keep looking at it so we don't miss any chats. Um, all right. So we have all our total analyses in there. Now we have Seahawks performance against total. Okay. How a single team performs against spread slash total over the course of a season. Okay, so that's Seahawks performance against total for those years. Now let's go in, and we don't want performance against total, we want performance against spread. PAT, we're going to get PAS. Performance against spread, and title. Now let's show the plot. I'm going to redo this real quick and do a legend. All right, then plt.legend. Didn't show it. All right, and that we could kind of just move it over here. Okay. So that's just the documentation from last time we wanted to do. Now, and this is what we expected, sinusoidal. Um, okay, so we've got this stuff. Now let's go see if we can figure out how to automatically generate our region. So, I think actually I'm going to upload the repository first. Actually, no, I won't. That'll be a pain in the butt. So let's just make a new script. Let's do it in here. Now this total analysis we ended up not using. Um, as we used. Then we have functions. Um, now let's do a new file, and this will be called generate. Um, okay, let's think. Um, all right, now if we go into plots, I'm trying to figure out how to get um, something from the functions in a subdirectory. So let's go Python 3. Now, if we go from functions, is this running? No. All right, so we could go from functions, get import, get previous data. So that's what we want to get from functions. Yep, no module named functions. Now I'm pretty sure we can say os dot change directory, go up a directory, and then we should be able to access it, I think. Hell yeah. Okay, so that's all we need to do. So let's make a new directory called analysis analysis1 analysis1 trend 3. Okay, so new directory for analysis1 trend 3. Now let's go make a new file in that directory. Generate region.py. Spread history data. Am I not in there? Ah. Now let's remove that directory. All right, remove analysis1 trend 3. Now let's go up a directory and then make that directory again. Now spread history data. When we go back in there, it should pop up. Yep, there we go. And that's where we want it. So generate region.py script for automatically generating the region identified in analysis 1 trend 3. Now we're gonna go back here. I guess we could just put it in here. Now we're going to say, how does this trend look? for previous years. So if we do analysis 1, but we want to change it around so that it doesn't do every year. Um, all right, so this we're going to change to a function. Define get analysis, yeah, we'll just say define get analysis of data of df. df will be our data. Then let's go bump all this in. Oops. Bump it in. Now we could say this returns wins, losses, and then we could say wins, losses is equal to get analysis of df. And then years, seasons should be a list, and the default is all of them. 2008, 2009, 2010, 2011, 2012, 2013, 2014, 2015, 2016, 2017. I wonder if this is easier with numpy. I'm not that used to numpy, so let's see. Import numpy as np. Now we want to do np.arange, and we want it to go from what, 2007 to 2021. 2007 through 2022, I guess. Nice. So the default should be np.arange 2007 to 22.toList. np.arange 2007 to 2022, and then we're gonna do .toList. All right. So it default gets all seasons. Now, right, so data, so this should actually go down in here. And, yeah. All right, so the first it gets the default. Now let's just go get it for every season. So, this we could just call plot analysis. So we want to plot the analysis, and we want to plot the analysis according to some years. So that looks good. Wins, losses equals get analysis df, and then seasons is equal to years. Plot home versus away odds. Now, okay, so here we do, we're gonna put all the test crap down here, and then All right, so plot home versus away odds now. All right, so if plot home v away odds is equal to true, then we're going to say plot analysis of years of mp dot mp dot a range 2007 to 2022 dot to list. All right, plot analysis of years. Um, all right, that's not so bad. Now if get year plots is equal to true, um, right, and then Boolean for get year plots. Not this. Then we do for year in np dot a range 2007 to 2022. Turn that into a list. And we're gonna do plot analysis I forgot those. Seasons isn't referenced. So let's just do this. Okay, then we do plot analysis of, make a list, and in that list is just year. Um, now, okay, so up here, seasons is never referenced. So let's see. Do we want to give the minimum season? All right, min season max season is equal to min of seasons and max of seasons. Okay, so now we've got that. Now we want to say that df is equal to df dot where df dot year is greater than min season, greater than or equal to min season. And then the other condition we put on here is that, remember we have to use the and, df dot year is less than or equal to max season. So now we've isolated the data frame. Let's put the debugger in there. All right, now let's run it. Get analysis, get your plots, plot analysis. Yeah, so that's gonna call get analysis. Let's just test get analysis as well. Test get analysis is equal to 1. Take that one off now. If test get analysis is equal to true, then we're going to say get analysis of df, and then seasons, (2010). So I guess it has to be concurrent seasons with this. Um, do we just add conditions? I mean, um, for season and season, um, let's say conditions is equal to that. Now for season and season, conditions dot append, and what should the condition look but like? Um, df dot year is equal to season. Oh man, this is rough. So now all seasons is equal to np dot a range of 2007 to 2022. All right. And then turn that into a list. All right. So we're going to say all seasons. Now missing seasons is equal to um, season for season in seasons if, oh, season for season in all seasons if, so let's just see if this works. I think this should work. So list one is equal to, let's say, 2007, 2011, 2015, and 2020. Um, and then L2 is just all of the seasons. So again, a range, get NP array in range 2007 to 2022, turn that into a list. So then L3 is equal to I for I in L2 if I not in L1. And then let's look at L3. So it should be I for I in L2 if I not in L1. So it should be basically the missing seasons, all seasons from 2007 to 2021 except for 07, 11, 15, and 20. 07, 11, 15, and 20. Nice. So that's missing. So we know that that's valid logic over there. Bring the chat over here so we don't miss anything. Um, all right, so now we know that that works. So missing seasons is equal to season for season in all seasons if season not in seasons. So that's kind of seasons for, oh, oops, season for season and all season. So missing seasons equals season for season and all seasons if season not in seasons. But that's okay. I know what it means. Now let's put in the debugger. So for season and missing season, then we're gonna append to the conditions. For season and missing seasons, we're going to append the condition that it's not equal to that season. And then what it should do is eliminate everything that's in that season. So now for season, oh no, we could just say for condition and conditions. For condition in conditions, df is equal to df.where condition. df.where.condition dot drop NA. And then we'll put the debugger in and see if that makes sense. So test get analysis is on. Cool. So let's say 2008, 2009, 2017. All right, cool. Now let's do test get analysis. Oh yeah, and then it'll put the debugger in there. So let's exit out of here so that everything reloads. And then, oh no, we should just run the file. So we could just do Python 3 analysis 1.py. Cool. So let's say df. Now what's df dot look like? Df dot year. And then how do we get unique values from a data frame? Oh, and what were the things 2008, 2009, and 2017? So that's obviously wrong. It didn't get anything in missing seasons. Min season, max season is equals to the min and the max of seasons. All seasons. So we did specify seasons here. So seasons is 2008, 2009, 2017. All seasons is equal to that. Missing seasons is equal to season for season and all seasons. So what does seasons look like? So all seasons do get passed in. Test get analysis. But here we're only passing in 3 seasons. So what's going on? Win condition. Do we have 2 debuggers in here? Oh no. I guess it goes through twice? Get analysis. No. I'm kind of confused on this. Let's run it one more time and see where we end up now. Seasons. How are we getting all seasons? Huh. Okay. I've got to go to the bathroom and make more coffee, so I'll be right back. All right, so let's go back to here. And so what are we trying to do? Our question is why is get analysis not passing in the right number of seasons? Why is it not passing in the right number of seasons? All seasons is equal to np.a range. Okay, season for season in all seasons, if season not in seasons. If season and missing for season and missing seasons. So our big question is why isn't seasons being read in? That I'm honestly just baffled. So let's continue here. All right, then go into Python from analysis one, import get analysis as G. All right, then G of G and then data frame. And then, okay, so G of DF 2007 seasons. Okay, nice. Now that works fine. What the hell? What's that thing it's printing at the end? Oh, wins and losses. All right. So then this just calls get analysis of data frame seasons is equal to that. Why is that not being passed in? This is truly baffling. Did I not save this file? Test get analysis. Test get analysis is equal to 1. Oh. Plot analysis. Nice. So we don't need this actually. Okay. Now I think this makes sense. Now we should, when we do seasons, it should just be our seasons. Seasons, missing, seasons. Nice. Okay, and then the last thing we want to do is say df dot, yeah. How do we get unique values? Pandas, data frame, get unique values. Dot unique, so df dot year dot unique. Cool. Nice. So that did exactly what we wanted it to do. Now, turn that to 0. Plot home versus away. Oh, All right, now I got a coffee. So, if we're gonna do plot home versus away odds, um, so instead of that, let's just try to plot one season. Say plot analysis of 2007. Let's just look at 2007, then we'll say. Um, Plot home VOA odds is 1. Now let's look at this. Continue. Nice. So if we had just 2007, then our region down here would look like this. These few bets. And so it's just not a lot. 1, 2, 3, 4, 5 bets in 2007. um, 2008. So if this is an edge, this is a pretty weak edge because we just can't exploit it very much. Let's look at 2008, how they did. More kind of all over the place. There are these in this region down here. Um, so it's kind of hard, kind of challenging to figure out how to draw that region. Um, so that's my question. That's what makes it kind of hard. Now, if we're just going off the previous years, that could make it hard, but if we do say every year before 2016, that should give us a fair amount of data. 2009, 2010, 2011, 2012, 2013, 2014, 2015. So yeah. So let's see what this looks like. Do we get a nicer chunk of data? How full screen? Get out of full screen. All right. So let's go check this out now. Continue. Yeah, so we do get actually a much nicer region if we use more data. Um, Question is just how do we define the region? Machine learning classification. I just was reading about this yesterday. So maybe we could just try to do a classification to classify everything as a win or a loss. The class for the normal state is assigned to the class label 0. So we probably want to reorganize this. For year in NP dot range, we want to say plot analysis of year, but also plot analysis of, now if year greater than 2007, plot analysis of NP.A range 2007 to year +1, and then turn that into a list. Okay, now, so if the year is greater than 2007, we want to plot the analysis for all years preceding it, not just the year. Now, we also should have a save name. Should be string, and it defaults to none. If save name is equal to none, then show it. Otherwise, if slave name, if save name is not equal to none, then we're gonna save the fig at the save name. Now, we're also going to say, just to handle this, it should be PNG or JPEG. So if save name dot split, so if we split the save name on the period and get the last element, it should be PNG or JPG. So if that's not in, and then lower case, because you could make it uppercase letters, and if that's not in PNG or JPG, then we're going to raise exception and say, please specify PNG or JPG format for the file, and then save name is invalid. Okay, so now we have the plotting happens. Now here we want to say plot analysis of year, save name. So first let's go into plots, get that out of here. Exit, cd plots. Now let's make a new directory. Um, Total analysis. And then can we move PAT versus PAT to total analysis? Ah. So now if we go into plots, oh. Now let's remove this. I want to make it total analysis and then move it in there. Nice. Now we want to move swing versus performance against spread to total analysis slash swing versus performance against spread. And then finally, no, it's just swing v swing, swing v swing, swing v swing. Okay. Now let's make a new directory for the plots we're doing right now. Just analysis 1, trend 3. Okay, now let's say plot analysis of year, and then save name is um, plots slash, what do we just call that? Folder analysis 1 trend 3, analysis 1 trend 3 slash year dot png. And then this one will be, the save name will be all right, so function string, then we're gonna do plots. So same thing, plots slash analysis 1 trend 3 slash um slash 2007 through year, and then dot png. All right. And then I think that should run. So get year plots is equal to true now. Let's take off plot home VOA odds and run it again. What? Oh. Python 3 analysis 1.py. Can't open file analysis. Oh. Oh man, that's gonna be a headache. So let's get rid of this. And that's because that won't stop. It's gonna open the debugger every time. So we had to remove that line. Now let's go back here and go cd spread history data, and then Python 3 analysis 1.py. All right. Oh, now, damn it. Axes limits cannot be nan or inf. So where are we getting nan or inf from? For item and data.keys, access limits cannot be nan or inf. Okay, so if okay, so access limits cannot be nan or inf. So it's trying to get these of limits. So Python get min or max without nan. Nan min, will that work? That'd be not nan min. All right, so let's just try to replace these with np dot nan min. All right, so think np dot nan min. Yeah, nan min. Is that what it was? Yeah. Okay. Cool. Probably nan max will be the same thing. So, all right, now almost done. Just two more here. All right, save it, and let's see how that does. Damn it. How did that happen again? Oh, no, it just ran. Okay, so it should be in here now. Nice. All right. So we have all our years. Now let's go look at what these look like. All right, so we start at 2007, add in 2008, add in 2009, add in 2010, add in 2011, add in 2012, add in 2013, 14, 15, 16, 17, 18, 19, 20. I mean, when does it first show up? Because even in 2007, there's this. 2008, still the same trend basically. 2009, you get more of a trend. 2010. Now here, 2011 is when it really starts popping up. Yeah, so what we want to say is if we did this trend, we want to get something that trains on this data and says, okay, here's the region to make picks in based off data from, say, 2007 through 2012. Then we want to say, um, okay, open this up. So yeah, this is 2007 through 2012. So we've trained it on this data. Now we want to say, okay, draw a bound for where we should make picks. So it might look something like that and that. So picks that fall in here, make them. So we would get a bound trained on this data, and then for the new points for the next season, we want to say, hey, we're going to make every bet that falls in that region, and then we want to see how it performs. And so our trouble here is figuring out how to define the region. Um, so that's why I'm trying to find out how to do a classification thing. To find a region. In a plot. Hmm. All right, so let's just see if we could do scikit learn classifier. I guess I've already looked that up. Yes, this is what I wanted. So I'm thinking that given this, we should get some drawing on the points down here. Lower right shows classification accuracy on the test set. All right. Range equals or ds count and ds and enumerate ds data sets. Data sets make moons. Oh, okay. So that's scikit-learn data sets. So we could do a classifier. How to highlight a region. What I'm thinking is that we can basically use two lines and move one line this way. And the other line could kind of be fixed at just below this line. So what does that line, that our line should be a little bit below the main trend line. So our line should be a little bit below the main trend line. So show plot should be Boolean and it defaults to true. Yeah, may as well. Default to true. If now this just becomes if show plot is equal to true. And then, but we want to save it before we show it. And then this would be if save name is not equal to none. So we have that. Now we want to try drawing a line that's just below here. So where should that line be? Where should our upper bound line be? It should be the same as this line, but minus some amount of odds on the y-axis. And so 0.5. So how do we get the probabilities from the odds? We do if odds greater than 0, the probability is odds divided by 100 minus 1. So let's say you're plus 400. 400 divided by 100 is 4. Oh, so then it would be the inverse of that. So 1 in 4. Okay. So if odds are greater than 0, then the probability is just 100 divided by the odds. Otherwise, if the odds are less than 0, then the probability is equal to then the probability here is the same as 1 in 4. Man, I'm having trouble thinking about this. So If odds are greater than 0, then probability is 100 divided by the odds. So if it's plus 400, then you win $4 for each $1 you bet. And that means the probability is 20%. So it should be, I guess, 100 divided by odds plus 100. Um, all right, if odds is greater than 0, probability is 100 divided by odds plus 100. So say odds is 300, then the probability of that team winning would be 25%. Does that make sense? To convert, divide the probability by 1 less than the probability. Oh, right. So probability is 25%, odds are 1 to 3. Yeah, so I was doing that right. So probability is 25%. To get that, then the bottom needs to be 400, which means the odds needs to be 300. Now, if it's less than 0, then we're saying that if you bet 400, then you win 100. Or if you bet, say, 300, then you win 100. So that's 3 times. So um, yeah, I'm confused on the negative. So 25%, which can also be expressed as 1 to 3. Now, if the odds are 3 to 1, okay, then we need it's odds divided by 100, which gives us 3, right? Yeah. So then what do we do? Odds plus 100 divided by 100. So now that would give us 4. And then we do 1 divided by that, and then 1 minus 1 divided by that. So if the odds are 300, this would give us 400, 4, 1 divided by 4, 0.25. Yeah, so 0.75. Yeah, so these are our equations. Now, if we multiply this by 100, that cancels out. Then multiply the top by 100, it becomes 100. Does that still hold? So 400, 100 divided by 400 is 0.25. Yeah, so 1. Yeah, so 1 minus 100 divided by. Okay, good. Um, oh, but it's minus 400. So it should be odds minus 100, because then minus 300 becomes minus 400. 100 divided by minus 400 is minus 0.25, so that should just be 1 plus. 1 plus odds minus 100. Okay. Um, Now this is if the odds are straight up. So straight up, 50-50. Um, Now reality is that it's about 55-55. The sports book wins at 55%. 55%. So, oh, hi, John Paul Tamol. The Philippines. What test did they fail? That they failed the test. Hi, John Paul. What test did the Philippines fail? Hello to the Philippines. Philippines is cool. How do you like it there? For loop. My for loop? Sorry, I didn't mean to type that. What do you mean? My for loop failed? Philippines failed the for loop test? What? I don't know. I'm confused. Philippines failed the for loop test? Are you there, John Paul? Not sure what you mean. Um, oh, your test failed. Are you doing code right now? Are you coding? Or are you trying to follow along and do this code? Did you, are you doing the tests that I'm doing and your test failed? Let me know. We could troubleshoot it. If so, um, okay. Comment which test down in here? Get year plots. Which tests are you trying to run that failed? Okay, so I'm trying to, we'll see if we can troubleshoot John Paul's test. Um, and until we figure that out, let's go back to figuring out odds. How do we want to do odds? So the sports book wins at 55%. Um, now, this line that I did right here would be 50%. If the sports book won at a 50% rate, everything would follow along that line. Um, that's okay. Everyone's a beginner. Uh, yes, but it could be hard to follow along. Maybe I'll do some coding tutorials on my channel because this is a little bit more in depth and this is hard to follow along. Are you, so you're just starting in Python? Is Python your language or do you not have a language yet, John Paul? What language do you write in? And also comment what you like about the Philippines. What's the best part of living in the Philippines? I like to ride bikes. I like to ride fixed gear bikes, so I know that that's kind of big out in the Philippines. Lots of people like fixed gears. Um, oh, you don't know what you like about the Philippines. That's fair. Um, oh, or you don't know what your language is. You don't know the Philippines or don't know what your language is. Okay. Let's see if we can uh, let's get John Paul set up. So you don't know what language to use? What? Okay, cool. And what operating system do you use? What kind of computer? Um, so this line is if the sportsbook wins at 50%. We want to get a little bit lower and assume that the sportsbook is going to win at 55%. Um, so I just have to figure out what that probability is, and then we could add that as our y-intercept to shift the line down. So the sportsbook wins at 55%. We want to see what odds are associated with that. So I guess this is just an algebra problem. Do 55 equals 1 plus 100 divided by odds minus 100. All right, John Paul. Um, if you're just starting in Python, you can download NetBeans. Man, I used that once right when I first started. So let's go look at NetBeans. So NetBeans is your IDE, I'm pretty sure. And that's where you can edit code, IDE, integrated development environment. So maybe you can install things in there. Um, Maybe I'll just download it. I wonder how long it takes. Um, where's their Windows installer? Oh, right there. Okay, yeah, you already downloaded John Paul, but I'm trying to figure out how to, um, I'm downloading it so I could mess around with this, and then we could figure out how to get you set up. Um, Basically, what you need is you need Python on your computer to use Python. So the first thing is if we go to the Python org, they have you already downloaded this stuff? Um, so like you just download whatever it is for your computer. I have Windows, so I would download it here. So go to here, go to downloads. Um, and then get your most recent Python if you don't already have it. If you already installed that with NetBeans, then you should be good. But I think you're going to need to install Python to actually do anything with NetBeans. Um, where has this downloaded yet? Okay, hopefully this will set up quick, then we could figure this out. Um, let's see. Okay, this is going to be a pain in the butt. This is So this looks like it's for Java. Can I use Python with NetBeans? Oh yeah. Never mind. I guess you can use Python for NetBeans, or can use NetBeans for Python, but I'm not sure if it's totally made for it. Now, oops. I know there's PyCharm IDE. Let's see if you need to install Python. Um, So you're trying to get this code to run on your computer. So yeah, John Paul, have you gotten Python code to work in the past? Or is it your first time? I'm wondering if you've used Python code before. Because if you haven't used it before on your computer, then that's why the for loop isn't working, and we need to get it installed on your computer, which you can do here. Okay. Um, so you need Python on your computer. I'm just gonna go to PyCharm because I know that they have it. Um, I wonder PyCharm might be nice because it might already install Python for you. No, they tell you to go install it here. Yeah, so this isn't the thing I use. I'm using VS Code. If you want to use the same thing as me, you can download VS Code. Um, Otherwise, here's what you should do is follow the instructions on here. So go to that page, follow their installation instructions, and then once you have PyCharm on your computer, this live stream will be over because I have to go to work. But you can, let me see if I could find a good tutorial. Uh, you want to, it's called Hello World is always the um, the first tutorial that you want to do. So go to that page, get PyCharm set up. Um, and let's see if this is good. Nice. So this will be a good video to get you started. Check out that video. That's really simple. After looking at that video, all right, that should get you started. Um, uh, yeah, good luck, John Paul, on your Python journey. Everyone, the hardest part is starting out. And if you could just, get started. The whole key is get started. It's confusing, it's frustrating, and it's difficult. And basically just keep stumbling through it, um, and you'll be good. Yeah. So back to the code. So we want to offset. Get that out of here. So we want to offset this line down. So where this line is right now is assuming that we're winning. The sportsbook gives us odds to win at a 50% rate, but that's not the odds that they give us. They give us odds to win at a 55, or no, they give us odds to win at a 45% rate. Um, well, either way, it's off by 5. So now this is just an algebra problem. So 44 equals 100 divided by odds minus 100. Now, so 100, we're going to divide and then invert. So 100 over 44 is equal to odds minus 100. And then, okay, so odds is equal to 100 over 44 plus 100. All right. If we put that in, 102. So we're trying to think. So when the sports book, what they're giving is what they see as an even bet, instead of giving it to us at plus 100, they give it to us at plus 102. This seems off though. I think that instead of 44, so 45 gets us 44 on the bottom, 55 would get us 54 on the bottom. Huh. Yeah, so I guess I'm just kind of confused. So where did this come from? 1 plus 100. So this is finding 1 plus 100. Oh, this should be 0.45. Duh. Okay, so now that becomes not 44. 0.45 minus 1 is minus 0.55. All right, now this should be good. So 100 divided by minus 0.55. So if the odds are minus 81, but that's what's, so yeah, so 0.45 is equal to, So I'm just trying to think. There's something wrong here, something wrong with how we're figuring it out. Maybe this needs to be 0.45. Yes, okay, that's what we were trying to get. So instead of giving us odds at minus 100, they give us odds at minus 122. Um, so we're going to want to shift this down by 22.2 repeating. So let's go ahead and draw that line. So plot analysis, annotate, and this should be Boolean. We're just going to start out by making it true. Okay, now we've done all our plotting. Now we say if annotate is equal to true. So if we want to annotate, then we're going to want to draw a line under there. Draw a line under that region we're looking at. And the line, so the x lim goes from here to here. So let's take this out and make it its own variable. So we can say x min x max is equal to this, and then y min y max is equal to this. Y min y max is equal to that thing, 1.05 times NP. Oh yeah, extra parentheses at the end. So now we've got that. So if annotate's equal to true, we want to make a line. It's not that confusing. It looks confusing, Cypro, but it's not that confusing. That's funny though. Put you off wanting to have a coding career. No, coding's fun, man. Um, you'll see. You'll see by the end of this, once I finish this analysis, and then I'm able to get money for free by betting on football games or any type of game. Or if you like, you can do this with stock market or crypto. All you need is to code, and you need data, and basically you need to know how to code, and you need time, and you need a good attitude, and you could get money for free. You don't have to work. That's what I'm trying to do. I'm trying to quit my job so I can have money for free. So to do that, we got to annotate this plot. So if we want to annotate this, then we're going to get a line. So line, so line x is equal to, we're going to go so everything in range from x min to x max. I don't know when I'll be finished. It's kind of like a non-stop process because you're like what we're trying to do right now is look at. So the first thing I did was get the data set I have. And then the next thing I did was try to analyze and pick out trends. Of the trends that I picked out, this is one of them that I thought was interesting. So you look at the data, you get the data. Once you have the data, you look at the data to try to look for trends. If you find any interesting trends, you try to isolate them so that you can exploit them and take advantage of them. And then basically how to make money from betting or the stock market or crypto market or whatever is that you get a trend and that can make you a little bit of money. But then the trends, it's a free market. So trends are constantly like popping up and then they disappear. People learn about a trend and then once it gets exposed and everybody learns about it, then the trend goes away and the market becomes more efficient. So uh, basically the strategy for this or any type of making money on any type of free market is that you collect a series of strategies. You have like maybe 50 different models that you're using, and each individual model is successful at making picks, and kind of using them all together, you're able to eliminate the risk of one of the models failing. Because since you're dealing with real-time data and there's chaos and uncertainty, then the models will fail from time to time. So that's like the downside is you need to protect yourself from the model failing, and you protect yourself from that by having a lot of models that work. So I'll be done with this work once I have a lot of models that work. Right now I have no models that work, and I'm trying to get the first model that works right here, and that's what we're working on right now. So we want to get this line down here that's kind of going to be offset a little bit that accounts for the fact that we don't get straight up odds. Um, Now we need to get the times for that line. So, or the x values for that line. So the x values for that line is NP. So it's range x min to x max, and that's good because the x min and x max goes a little bit beyond the data. And then line y is equal to um, x. So negative x. So that was the first relationship that we plotted. Um, plt.plot np.linspace. Oh, okay. So actually the line x, it's even easier. We could just do the same thing that we did from here. We can say that the line goes from minus 20,000 to 20,000 in increments of 100. Um, then the line y, oh, yeah, line y is just the same thing, just minus line x minus, and then we want to subtract here by the amount that we want to increment it down. Would you sell the programs or models to people? SciPro comments. Yes. That's there's kind of two ways to make money. The one way to make money is you can use the models for yourself. The other more sure way to make money is to sell the models to other people. So yeah, that is what I would do um, eventually. Actually, I don't really have much of a plan. Really, I think you could kind of give the models away for free to an extent, because then the edge will go away if you give the model away for free. But also, if you give the model away for free, then you develop a reputation as somebody who could build good models. Um, and that reputation is worth a lot, especially if you're in the world of like coding and data analysis. You want to be known as the guy who makes good models. So it's not all about money up front. So I don't know what the best thing to do would be. Um, but yeah, that's what most people do is they sell the model or they use it themselves. Or you use it yourself and then you don't, people also, the most common thing is to not actually sell the model itself. You have the model on your computer and then you sell what the model spits out. So that's, I think, the standard way to make money. We were just looking at it yesterday. I'll get back to coding in a sec, but there's this cool site um, that has NFL ELO data. ELO, if you play chess, that's how they do the chess ratings. Um, yeah, so this guy puts out his confidence pool. Well, actually, he puts out a lot of things you can look at, but this is the confidence pool. And yeah, you get basically the winner of the game, and then he ranks them in order from most confident to least confident. I don't know how he did this week. It's NFL, so there were games yesterday. But you can see he assesses how his model does over time. Um, where is it? Oh yeah, so he did last week recap. So he won all the main games he picked. Um, anyway, so people do stuff like this here. So if you go to this guy's site, he actually gives it away for free. I don't know how he makes money. Maybe advertising, or he has a big following on Twitter too. Um, but he lists it for free, but you can't find his model anywhere. You don't know how he's getting these numbers. You don't know how he's spitting them out. So that's another way that people make money. So this, we're gonna want to segment it down. Instead of minus 100, it's giving us this minus 22.222222 repeating. So we're going to subtract that amount, 22.2 repeating. And then we're going to want to plot the line. And let's see how this looks. Oh, this is if annotate equals true. So we're going to want to put this in here, plt.plot, line X, line Y, color is equal to red. Label should just be offset line. Oh, oops. Wrong line I was typing on there. All right, now this should run. Get your plots is true, so plot home versus away odds. Yeah, so let's get rid of this and just say plot analysis of 2007. I mean, yeah, that should be fine actually. So we can say plot analysis of 2007, show plots true, annotates true. Okay, nice. All right, now let's plot it. Lin X. Line X. Fix my typos. Now let's run it again. Nice, okay. So that gives us the offset that we wanted. So we want to get bets that are in that region. Maybe we could just do bets that fall below that line. Is this getting all years? Oh. Does it do a unique plot for each? Yeah, it does. Well, that's a pain in the butt. df.seasons. I wonder why it's doing that. Oh, get year plots. Oh. Well, we'll just have to keep exiting out of these. Man, that's a pain in the butt. Actually, let's just go get out of here. Close that down. And then let's change. We should be able to change the plot. Yeah, let's change the plot title. Now, if title is equal to none, then make the title wins versus losses. Otherwise, make the title whatever the title we pass in is. And we should be able to do wins versus losses, and then year. year for year in years, and then say season. Seasons. And I guess we could say season. Want to say, damn it. Okay, so we want to say season if len of years is equal to 1, else we want to say seasons. All right, now let's see if that works. Year for year in years. Oh. Single. Okay. Get rid of that. Now let's run it again. Damn it, still forgot to turn plotting off. For year in there, plot analysis of year. Well, this we actually just want to turn the middle one on. 1. All right, now let's do this. Python 3 analysis 1.py. Nice. Well, that's an ugly title, but that's okay. Now, if we zoom in on the area we want, man, there's just a good grouping down here of bets that we should take, which makes me think that we could use a classifier. Oops. All right. So now the question is how to draw the second line. We can optimize where we draw the second line based on... Okay, so we want to get the points in a region, because what we can do here is, I think I'm going to say, hey, when we're finding the region we want to draw for the previous season, we could say, hey, just draw a straight up line right here, and put it somewhere along here. And then once we have that line, say it's like here, then it'll just be get all bets in this region. So now what we want to do, plot analysis of years, save name. Where do these intersect? Where will they intersect? I guess we could easily find where they will intersect. And then we could use polynomial stuff to figure out which ones are in the region. So we've colored this. Now let's go to our Trello board and we could update what we're trying to do here. So figure out how to define region. And edit that to also be, oh, not bottlenecked, bottleneck reliever. Okay, so we've got our first line to define region. First, define region lies just below the ideal. Second line to define region will be a vertical line drawn somewhere on the plot. Now, function gets, so then we need a function to get, function to get total value returned if, all right, so then we want a function to get the total value returned. And we want to get the total value returned of bets that were in the region. Then we want to feed function through optimizer to determine the best placement for the second line. All right, so those will be our steps. We could add a checklist for that. Remember, one of the most important things when you're coding is not coding. It's keeping track of your project, because if you just try to get down to coding, you're going to be inefficient and waste a ton of time. So we've already defined that first line. Write function that passes in a x-intercept for the vertical line. So we want to get a function that passes in the x-intercept for the vertical line, so basically the placement of the vertical line. That passes in an x-intercept for the vertical line and seasons of data to look at. All right, so write function that. All right, so the first thing the function does, damn it, passes in an x-intercept for the vertical line and seasons of data. Passes in an x-intercept for the vertical line and seasons of data to look at. It returns the total write function that passes in an x-intercept for the vertical line and seasons of data to look at. It returns the total money returned had one placed a bet on every bet that falls in the region. Okay, that was kind of long, but that's what our function should look like. Now, right now, optimize function to get the ideal region according to training data. All right, so optimize function to get the ideal region according to training data and test on test data. Now do this for each year from 2016 to 2021 using previous year's data for training. All right. Now I have to get to work, so that's what's going to be on the next live stream is I'm going to write that function, then I'm going to optimize. I'm going to write another function that optimizes that function. Then we're going to write a function that says, hey, get the region, do this test where we go through for each year from 2016 to 2021. We're going to use the data from all the previous years going back to 2007 for training data to get our region. And then once we have our region, we're going to test it on the test data, say how much money does it return. And then we're going to look at that to see if we actually have a strategy that we can exploit to make money. So thanks for watching. That's it for this live stream. Thanks to CyPro and John Paul Tamol for commenting. Hope to see you guys on the next live stream. If you guys liked it, please subscribe. Thanks for watching. Have a good rest of your day, and good luck.